Hello, today's class is about oxidation with chromium 6 compounds. So we discussed earlier also oxidation with manganese 7 compounds. Today I'll take up the lecture on oxidation with chromium 6 compounds. Okay. The common reagents which are used, chromium 6 compounds which are used are mostly chromium trioxide and sodium or potassium dichromate. So I write down here the common reagents, or you can say oxidants, which are used as chromium 6 compounds. Chromium 6 compounds are say like chromium trioxide, CrO3, and chromic acid, H2CrO4, and then this dichromate, sodium or potassium dichromate, K2Cr2O7, and then we have PCC, pyridinium chlorochromate, etc. So most commonly with out of this one, we have mostly used chromium trioxide and chromic acids. Actually, let's see first one. Let's start with chromium trioxide. Actually, chromium trioxide is a polymer. Chromium trioxide is a polymer. Okay, so it can be in presence of water. It dissociates into in presence of water. It dissociates into chromic acid. In presence of water, it dissociates into chromic acid. Okay, so I'll write down here. So chromium trioxide is a polymer which will react with water. When it reacts with water, it gives chromic acids, HOCr, or just like sulfuric acid. Okay, this is chromic acid. So chromic acid can have another one, can have also dissociate as a polymer like this with this chromate ion, like this is positive charge. So this chromate ion can have in equilibrium with say in equilibrium with dichromate ions, dichromate or Cr or negative charge. So this is dichromate plus water. Okay, so in the two molecules of this one, so we have, so they can be dissociated to this in equilibrium between this chromic acid with dichromate. You can write like this one, 2HCrO4 negative charge here, one negative charge in equilibrium with Cr2O7, two negative charge. Okay, so two negative charge. Chromium are two chromium atoms and 7. Okay, 1, 2, 3, 4, 5, 6, 7 plus water. So in this way you can have in equilibrium, they can have two molecular chromate, can have dichromate and water like this. So the actually reaction takes place by this chromate and then chromium trioxide water, this chromic acid, and usually oxidation reaction takes place by this chromate. Okay, let's say now in the reactions of this oxidation reactions of organic substrates with chromate takes place, with chromium trioxide takes place by transfer of net transfer of 3 electrons. So I write down here the oxidation of organic substrates by chromium 6 compounds undergo net transfer of 3 electron systems takes place. So the oxidation of, I write down here, the oxidation of organic compounds, organic substrates or compounds by chromium 6 oxidants. Chromium 6 oxidants takes place by transfer of involves or takes place involves transfer of net transfer. We can say net transfer of 3 electrons. That is, chromium is oxidized to chromium 6 is reduced to chromium 3. Okay, so like this, chromium 3. So here 3 electrons, and the 3 electrons are transferred. Actually, in the oxidation reactions of chromium 6 compounds with our organic substrate takes place by actually in this test actually 2 electrons are transferred. So for example, I will give oxidation of secondary alcohols by chromium 6 compounds will give transfer. So actually in this step, so let's say for example chromium 6 reacts with this R2 CSOS. This is the secondary alcohols oxidation. 2 ketones R2 CO takes place by transfer of 3 electrons here. In this case, in this step, 2 electrons are transferred. So 6 to 4 are there. Okay, it is 4. 2 electrons are transferred for each step. So again, this chromium 4 can react with this is chromium 6. Then we got chromium 5. So we have 2. In this test, 2 electrons are transferred. So overall, the net transfer is 3 electrons. So one step, 2 electrons are transferred. Then chromium 4 reacts with chromium 6, chromium 5. Then this chromium 5 reacts with again the alcohol, secondary alcohol. So these two oxidize to ketones. Then we have here also same case H plus and chromium 3. Okay, so here chromium 5 to chromium 3 comes. So 2 electrons are transferred. So net overall reaction net transfer is we can have a reaction we can take place. So in this test, carry 1 from 6 to 4, then here 5 to 3 like that. So we can balance this thing. So here 2 are here, so you can have multiply by 2. So balancing this thing, we can have 2 CR. So here we have chromium 6. So here 5. So we have chromium 6 here, 2 chromium 6 are here, 2 Cr6 are here, plus this alcohol is 3, 2, 1, and 3 R2 CSOS, and here also similarly here also 2, 1, 2 ketones, and so here 4 plus 6 is plus, then chromium we have this is balance this one, and this one also this one, and then finally we have chromium 3. So net in the overall reaction is balance reaction is transfer of 3 electrons. The transfer takes place. So transfer is from 6 to 3. So this is the overall reaction. I'm giving one example like this. So I'm repeating again. In the case of oxidations with chromium 6 compounds, so there is a net transfer of, so you can say involves net transfer of 3 electrons. But in this stage, actually 2 electrons are transferred. So from here 6 to 4, and then 5 to 3 like that. So overall reaction is like this: 2 molecules of chromium 6 compounds can oxidize 3 molecules of this secondary alcohols to ketones. So here also 3, I think is 2 here, 2, 3, go like this. So this is about the reaction. So let's take a one by one. The oxidation of first one, oxidation of alkanes by chromium 6 compounds. So the first one is oxidations of alkanes by chromium 6 compounds. Okay, here alkanes are generally not oxidized by chromium 6 compound. Generally are not oxidized, but in drastic conditions. So generally you can write generally alkanes are not oxidized by oxidized by chromium 6 compound, chromium 6 compounds, or you can say chromium trioxides. But in drastic conditions, they can be alkanes oxidized to can be oxidized to alcohols, So one example I'm giving said one example I'm giving this one. This is alkane, substituted alkane. Here, and we have say methyl. So let's say ethyl here, methyl here, or here propyl or here. So okay, this is a chiral compound. So in presence of sodium dichromate or chromium trioxide in water, as a chromic acid or chromium trioxide, you can use ICl4 perchlorate. You can use chromium trioxide or sodium dichromate also. You can use sodium dichromate CaNO2Cl2O7 in water and some chloric acid, and that's in the presence of acetic acid in acidic conditions. So this can be the CS can be oxidized to COOH. Okay. Intentional configuration takes place: propyl group, methyl group, and ethyl group. So here, so tensional configuration takes place. So here, generally, I'm repeating again. Generally, this alkanes are not oxidized, but in the drastic condition, they can be oxidized to alcohols. Then let's say another one, second one, we can have oxidation of aromatic hydrocarbons. Oxidation of number two, oxidation of aromatic hydrocarbons. So aromatic compounds. So here mostly they are oxidized to generally are oxidized to aldehydes, and then further again oxidized to acids like that. So for example, I'm giving some examples here. So here CH3 aromatic hydrocarbons in presence of nitrogen, nitric acid, nitro. So here chromium trioxide in presence of chromium trioxide, and then sulfuric acid. So it can be converted to chromic acid, and then acetic anhydride and water. Okay. So here, so first this is converted to diacetate compound as an intermediate, converted to diacetate CH or COCH3 diacetate compound, and then this further acid hydrolysis, sulfuric acid and water. So hydrolysis, this will come to aldehyde. Okay, so aromatic hydrocarbons are oxidized to aldehydes in presence of acetic anhydride. So first is acetic anhydride presence. First is converted to diacetate complex. Okay, diacetate. So there are so many examples are here. So generally, we can not only using this chromium trioxide, we can use the chromium chloride, ClO2, Cl2. Chromium chloride also can be used, called chromyl chloride. Chromyl chloride can be used for oxidation of this type of aromatic hydrocarbons. So I will write the mechanism here using the chromyl chloride. Oxidation of aromatic hydrocarbons using chromyl chloride. Okay, so reaction will be, so let's say this is the aromatic, okay, CH2 is hydrogen here like this. So chromyl chloride in presence of CrO2, Cl2. So here first it is converted to like this. You can have air right down there. CH2. The chromium chloride is C double bond O, Cl2, 2 Cl are here like this. This is chromium chloride. So you can have first converted this, attack here, so here, and then attack like this. Okay, so we can. So here we got this intermediate air, CH2, O here, then Cr, this is Cr, chromium chloride, Cr, then O, pick up this port OH and Cl2, and this. Okay, we have OH here, and then you have Cl2 here, chromium chloride. This can react with another chromium chloride, CrO2, Cl2, so you can react with, so this OH can attack here, so we can have air, CH2, or chromium, so here chloride here, these two chloride are here, this, and the O attack another one, so here attack this chromium, okay, here OH, and the one O, Cl2, okay, so another attack, this O attack this chromium chloride, O like this, Cl, okay, so attack here, chromium attack here, and then O like this, so it goes Cl2 like that, okay. So now hydrolysis of this with water, so you got this alcohol, CH2OH plus, so the hydrocarbons are converted to alcohols, and we have chromic acid, H2CrO4. So this is the mechanism of oxidation of aromatic hydrocarbons by chromium compounds. So here in this case, chromium chlorides are used. Now let's have third one, oxidation of aldehydes and ketones by chromium compounds. So third one is oxidation of aldehydes and ketones, aldehydes and ketones. So aldehydes are generally oxidized by oxidation by chromium compounds. Aldehydes are generally oxidized to acids, and then these ketones are not generally oxidized, but they can be oxidized by cyclic ketones can be oxidized. So generally aldehydes are oxidized to chromium water or acids, sulfuric acid. So it gives two primary alcohols. Okay, CH2OH. So no, these acids, okay, are oxidized to acids, HCOOH. So here aldehydes are oxidized to acids. So I'll give the mechanism here, simple mechanism. Generally I'm giving the mechanism here. General mechanism of the reactions are like this. So here first is OH, okay, this one pass in presence of acids, proton attack takes place, CO ice, the ice, okay, then this is can be written as this way, R like this, RCOH, positive side here, and then here. Then this one attack by chromium compounds, text is this one. So write down here H2CrO4, okay, chromic acid. So here we have the intermediate R, CH, OH, we can write this one, O, okay, this is like O negative charge, Cr, O, one, OH, okay, like this. So he takes here, so he takes this one, so this Cr, we can write this CrO3H, okay. So this is the just here, so I'm writing this one here, okay. This is the chromic acid. So here now we have hydrogen here, so it attacks by base of water, and can undergo this way. So when they go like this, okay. So you got a acids. So product is OH, number one O acids plus CrO3H negative charge. Okay. So this is the plus H plus. H plus is there. Plus H plus. So this is the final product. So this is the how aldehydes are oxidized to acids. Okay. So I'm repeating again this mechanism of the reactions. Oxidation of aldehydes by chromium trioxide or chromic acid. So here aldehyde is passes proton attack in presence of acids to get this compound, and they have a resonance structure. So it positive charge carbocation is formed. So this is attacked by this chromic acid. So attack here. So you got an intermediate. They lost this. Another attack here. Chromium trioxide OH2, CrO4, chromic acid H2, CrO4. This is a reaction with chromium trioxide water will give chromic acid. Attack here. So remove this proton, and we got this anion, and then this one. So we got a final product. So aldehydes are oxidized to oxidized to acids. But aliphatic ketones are not generally oxidized. But cyclic ketones can be oxidized too with the cleavage of ring takes place. So here generally aliphatic ketones are not reduced but are not oxidized, but cyclic ketones, cyclohexanone, when you react with chromic acid H2CrO4, so it can be oxidized to dicarboxylic acid groups C. So here CH2, CH2, 1, 2, 3, 4, CH2, 4, CO2H. So dicarboxylic acid groups here oxidized like this. So here generally, I'm just repeating again, generally aliphatic ketones are not oxidized, but cyclic ketones can be oxidized. So let's see the mechanism of the reactions, how it is formed. So first, these ketones in presence of, say, you can have, so I write down here separately. So this is, can you tautomeric form, you can write ketone enol form. So here first, so let's say this way. Okay, let's write this way, better here. So here first will be like this, OH. So here hydrogen here will delocalize like this. So here takes place. So in presence of this chromic acid, Cr, OOOS, OS, O here, okay, chromic acid. So here this pass can come here, so it takes here, then loss of water here takes place. So here what this becomes the proton, so it is becomes the proton, loss of water. So what about intermediate fast? And intermediate is fast form. So here double bond here O, then have this O here, chromium, so you can write chromium 3 O is okay, chromium O3 is so like this. So here hydrogen here. So I'm repeating again this. First this ketones is tautomerized form. Tautomeric form right this way. Then I take this with the chromium acid. So we got O, Cr, how many? CrO2s, okay. O2s, okay, first this one. Then this one, reaction another chromic acid, H2CrO4, attacks here, so it gives like this. Attacks here, so it goes like this. So we got a product is diketone. Okay, diketone is of 10. So this diketone reacts with chromium trioxide, then chromic acid, chromium trioxide, and water. So I'll write down separately here. So here, oxidation of cyclic ketones. So here I got the diketone. So diketones I'll write down here, diketones. Here reacts with chromic acid, another group of chromic acid, Cr, OH, okay. So it takes this one to attack here. So they get pick up the proton from here and here. So they get pick up the proton here. So got a cyclic intermediate. So we have OH here, another OH here, and O here, and chromium, and then this O like this. So pick up the proton here they pick up, and here also they pick up. So we got a cyclic intermediate, this one. So that is diketone. Cyclic diketone reacts with chromic acid, got. And finally lost this cleavage of the bonds takes place to keep this one. Okay, so we got acid groups is O2, C. So here 1, 2, 3, 4, 4 CH2, then CO2H. Okay, so we got this final product. So here what I'm telling that, so ketones are not generally oxidized, but cyclic ketones can be oxidized to give dicarboxylic acid group. So this is about the oxidation of aldehydes and ketones by chromium compound. Now let us take up oxidation of alkenes by chromium compounds, oxidation of alkenes. So this oxidation of alkenes is generally not so important because it gives us lots of products. It gives many products, a mixture of products are obtained when oxidized, alkenes are oxidized. So we have, just for example, this one, this is general reactions, okay. chromium trioxide in water or chromic acid and presence of acetic acid or acetic anhydride. It gives lots of mixture of products. So we can get CAs epoxides groups can be obtained, plus this can be broken down, so we can get CSO, the aldehydes groups can be obtained. Then in presence of acetic anhydride, you can get OC, the bond OC like this, CAs like this, and there's so many products you can have. We can have, and this also can be broken down. It can be again the realization take place. So this is a mixture of product. We got a lot of mixtures of products we can get. So we've got aldehydes or ketones, epoxides, and cyclic intermediates, etc. can be obtained. So let's see how the mechanism of this reaction takes place. So first, I will write on the mechanism of the reactions. So you give it, so oxidation of these alkenes by commonsense compounds gives a mixture of compounds, mixture of products. So it is not so important for synthesis of the inorganic chemistry. So let's see how the mechanism of the reactions. So here, mechanism of the reaction here, say let's say R2, C, the one C, R2, okay. So reacts first with chromium trioxide, say OCr, OS, okay. So here first attack this double bond attack here, then this attack here, the loss of this is water, which takes place loss after protonation, water is lost, so we got R2, CR2, and this intermediate here, let us write here, OCr O2H, okay, CrO2H, this O2H, then this is positive charge here, so link up there like this. So loss of water minus water is lost after pick up the proton here, okay. So this one, when you can undergo many reactions, when you write it reacts with water, say reacts with water, this will give water will take here, OH will come here, so R2, COH, then Cr2 or CrO2H, okay. Then this another water can attack here, or another water can attack here also. You can have, I think, 1,2 diol, okay. COH, R2, like that. So water, another OH water attack here, and then will go like this. So we have 1,2 diol, 1,2 diol. So this is one product. So another one product is got. Here if you use some acetic acid or acetic anhydride, we can have. So let's say this is another A intermediate. Okay, first for timing, let's keep the intermediate A. And this one, when you react this, another one, this can attack here. This one O can attack here, loss like this. So you can have epoxide groups can be formed. R2, C. So here C, O here, O. This attack here and lost this one. So here R2, epoxide is formed. So another compound epoxide is formed. So here we can get like this. And this one, again, this one to diols. So we have first A, then one to diol, this epoxide. So this one to diol, I write down, okay, here. This one to diols can react with another chromium acid, one to diols. Okay, this one to diols react with another chromic acid, CR2, OH, okay. So when you react with another chromic acid, H2, CrO4, so we got a intermediate a complex O, so O, CrO like this. Then this OH2 one will attack here, so like this, O, CrO, chromic acid, okay. OH. So you attack here, another one, attack here like this, so lost water, so we got this intermediate, okay. this can be broken down into two, like earlier, like ketones. Can you have ketones like this? Like down here. Okay. So here first a ketone is formed, then like this, it gives like this, so like this. So you have two carbonyl groups are okay, 2R2CO. So here broken down. So here cleavage of the ring takes place, cleavage of the bond takes place. So 1,2 diols can undergo further reactions. The 1,2 diols can undergo further reaction with chromic acid to give this two ketone. Okay, so we got one product here. So we have 1,2 diol, ketone, and epoxide. Another one with this A. When this A, intermediate A, reacts with say acetic anhydride in presence of acetic acid, so acetic anhydride in presence of acetic acid. So attacks here acetic group attacks here R2 C. So like O will attack here, and like down here, down here R2 C O C CH3 double bond O. Okay, like the acetic group attacks. Then we have Cr2 O Cr chromium group, chromium O2H. Okay, so now this attack here, and lost this one. So I'll run here. Next step is here. So we got a intermediate OCC3 O, then this CR2 R2. Okay, so you have positive charge here. So loss of one proton, this will get minus loss proton, will get CH2 O, C1 CH2 O. So here CR2 okay, R2 here. So this again oxidized, this can be oxidized to double bond. Ketones can be oxidized to by chromic acid. It's CrO4. So here we got this carbon group here. So here so many products we can get. A mixture products are obtained like this R2. So here another product here. So 1,2 diols, epoxides, ketones, so many reactions. So the oxidation of alkenes by chromium 6 compounds are not so important for they have limited value for synthesis of organic compounds. So now, so one of the most important reactions of chromium 6 compound is oxidation of alcohols. So this is one of the most important reactions of oxidation of organic compounds by using this chromium 6 compounds. So here secondary alcohols are oxidized to ketones, and primary alcohols are oxidized to aldehydes. Okay. So this one. So I will give some examples here. So many examples are here. So it is applicable to synthetic compounds. So here CH3. So like secondary alcohols. So we have like this. Okay, so this is one natural compound. So here sodium dichromate and a 2Cr2O7 water. So breaking down to it can break down into chromic acid in presence of sulfuric acid. So here this will give this is secondary alcohols will be oxidized to this product. Okay, ketone. Okay, secondary alcohols are oxidized to ketone. So these are applicable in steroid system also. So I am giving another examples for steroid compounds. So voice, hydrogen. So this is steroid. That's the R here. Okay, I'm writing here. That's the R here. So steroid compounds. So when you oxidize this with the same compound, I earlier guessed sodium dichromate, Cr2O7, water, and presence of acetic acid. So this will be oxidized to this carbonyl group. So these are applicable mostly to steroidal systems. Okay, so here primary ring. Here R is here this one. Okay, cholesterol type. Okay. So here what I'm telling that many examples here. So secondary alcohols can be oxidized to primary to ketones. Okay, by using this chromium compounds. Another example is that chromium compound is used also in the, it can be used in the sulfuric acid, can be used also instead of using this acetic acid, or the most important reaction of this with acetic acid compound. Acetic acid, instead of using acetic acid, sulfuric acid also can be used. For example, another example is that another application is that this secondary alcohols mostly used in cyclic ketones, cyclic compounds, cyclic alcohols. So here sodium dichromate in presence of water. Here sulfuric acid is used. Sulfuric acid. So to be oxidized to benzene and toluene, and 0 degrees around 10 degrees minus 10 degrees Celsius. So it will be less in the, so it will be oxidized to alcohols are oxidized to ketone. So like this, second alcohols are oxidized to ketone. So many examples are here. I'm giving few examples. And aldehydes generally I'll give one. Aldehydes are oxidized to aldehydes. Primary alcohols so the secondary alcohols, primary alcohols are oxidized to aldehydes. Okay. So what I'm telling that primary alcohols are oxidized to aldehydes and secondary alcohols are oxidized to ketones. So I'm giving mechanism of the reactions, how the reaction takes place. So let's see, pass with the aldehydes. Okay, pass. Let's say aldehydes, or from conversion to aldehydes. Primary alcohols are R2CH. Okay, this is secondary alcohol, primary alcohols. Okay, this is secondary alcohol. Okay, let's say secondary alcohol. R2CH. You can write it this way or this way. Okay, this is secondary alcohol. Okay, so when you react with this chromic acids, CrO3 or water or chromic acid, so the text with pass the text here. Protonation takes place and undergo reaction. So I'm writing the pass. This way protonation takes place. CRR. So CH OH2 protonation takes place. Okay, in the presence of acids. Acids protonation takes place. Then lost this one. So we got this R CH positive charge R. Okay. So this one I take by chromic acids H2 CrO4. So you take here. So you get intermediate R CH. So you can O CR O2H. Okay, O3H. So we can add here another one O3H. Okay. So here O is here O is, so here negative charge is, so you take here this one, I take here, so like O, so here O3H. Okay, so here this intermediate, so take by this chromic acids intermediate, then loss, this will be lost, so this will be attacked by loss. So the loss is 1, so finally this give a, so we got this ketone. Okay, so secondary alcohols ketone. So Cr plus CrO3H. So that this is the mechanism of the general mechanism for oxidation of secondary alcohols to ketones. Similarly, you can have some aldehydes also can be oxidized like this. So this is the mechanism. But if we use chromium trioxide in presence of acetone, in presence of sulfuric acid, then you got Jones reactions. So oxidation of alcohols can take place by using Jones reactions. Jones reactions is that chromium trioxide in presence of sulfuric acid. Here and an organic compound or this organic alcohol is dissolved in fast alcohol is dissolved in acetone, yeah, acetone, CH3, CH3. So in a solution of alcohol and acetone, we put this chromium trioxide and sulfuric acid. So this is called Jones reagent. Chromium trioxide and sulfuric acid is Jones reagent. So it can be used. Chromium trioxide is used in sulfuric acid, then is known as Jones reagent. In this case, these alcohols are fast dissolved in acetone, then we use the drop by drop chromium trioxide and sulfuric acid like that. So you have so many examples right here. Submembrane, say alcohol. So here chromium trioxide, or you can say chromium trioxide and sulfuric acid. So this generally is white water. Okay, then the acetone, the acetone. So this that's in room temperature, around room temperature. So this is converted to ketones. So this submembrane is converted to cyclohexanol. Okay, so this is one of the methods. So it is known as Jones reagents. So another reagent is called Collins reagents. So you use here also Collins reagent in presence of pyridinium, pyridine. Collins reagents. Collins reagent is very good reagents which is widely used for organic synthesis. So here Collins reagent, here you use chromium trioxide in pyridine. Okay, mostly nowadays called PCC or pyridine dichloride, or generally compared this Collins reagent is structure is supposed to be chromium trioxide and pyridine. Two molecules have structure like this. Pyridine. Okay, this is and this O, this O, and this O. So here pyridine can be written like this. So here like this. So, okay, this is Collins reagents. So chromium trioxide and pyridine. So you can write this. Okay, well, you can write this with another structure. And here and here and pyridine complex form with pyridine, and this is O. This is O negative, another O negative here. This is positive charge, nitrogen positive charge. So this is another way you can write this one. So this complex is known as Collins reagent. So how it is reacted with? So secondary alcohols are oxidized to ketones by using these Collins reagents. So Collins reagent is one of the most important reagents for oxidation of alcohols, secondary alcohols. So let's see how the reaction mechanism takes place. I'll write here the mechanism of the reactions. Mechanism of the reactions. First is let's say, okay, this is the secondary alcohol. We have this secondary alcohol, okay, R prime, OH. This secondary alcohol that reacts with this acidification takes place with acid. So here alternation takes place. So you get CH, OH, 2, R prime here, positive charge here. You can lose this one, or you can attack. So with these Collins reagents, if you use these Collins reagents, so your Collins reagent can attack here. This Collins reagent attacks here, loss of water. So direct, okay. So you can have this intermediate R, C, R prime, S. So we can write O, CR. So we like pyridinium positive charge, another pyridinium positive charge. Then we can have O negative here and double bond O here. Okay. So this complex is formed. So when the Collins reactions reacts with, so I'm repeating again, this is secondary alcohols. Then in the presence of acid, proton attack, this then attacked by this, they lost this, so we got a complex intermediate. Then this again by another base or in pyridine attacks here, pyridine or molecular attack here, base will strike proton here, so like this. So you got a carbonyl group aspect, okay. So like that, okay. So in this way, the final product will be ketone. You got a ketone, you can see plus this chromium 4 compounds, chromium 4. Look at that chromium, I write down the structure of this one. Chromium is pyridine positive charge, pyridine positive charge, and O negative, okay. This is chromium 4 compound, 4 complex, chromium 4 here. So I'm repeating again, so in the using the Collins reactions, so mechanism is passes, this is protonation takes place after the proton, then from the acid, then attacked by this Collins reagent, water loss, got a complex, then pyridine base attacks here, pick up the proton, and then you got a ketone and like this. So this is about Collins reagent. Collins reagent is very famous for organic synthesis of generally for the oxidation of secondary alcohols to ketones. So here I'm repeating again that so alcohols can be oxidized to primary alcohols can be oxidized to aldehydes, and secondary alcohols can be oxidized to ketones. But tertiary alcohols can be are not generally oxidized, but cyclic ketones can be oxidized. Like say for example, say this type of hydrogen here. Oh, there's a CH3, some substituents here. CH3. So these are tertiary alcohols, okay, tertiary types. But generally, so I'm repeating again that generally tertiary alcohols are not oxidized. Primary alcohols are oxidized to aldehydes, and secondary alcohols are oxidized to ketone. But generally, tertiary alcohols are not oxidized. But this type of cyclic compounds can be oxidized by this chromium 6 compounds. So let's say chromium H2, H2 chromic acids in presence of water. So you can have water or sulfuric acids. Okay, chromium trioxide water also gives chromic acid. So here attacks here. So we got one loss. We got a cyclic intermediate first. So here cleavage of the bond takes place. Cleavage of the bonds takes place first. So here O will attack here, loss, and then this one loss. So you got an intermediate or CR or like this. Okay, what an intermediate form. So then this loss this one, this will be like this. So you got a that bond, that one is broken down. So you got this CH3, so here carbonyl group, then we have CH2, CH2, 4 dialeric acids, and we have CH3. So we got a cleavage, the bond takes place here, this type of bonds, we got these ketones. So this is about the tertiary alcohols can also be oxidized in the case of cyclic compounds. So this is about the, so I'm repeating again or summarizing this thing today. So Collins, this Collins compounds can be used for oxidation of say alkenes, and then for alkanes, then aromatic hydrocarbons, aldehydes, and ketones like this. But the most of the important oxidation is the oxidation of alcohols using this Collins compound. So one of these is Collins reagents, Jones reagents are used. So Collins reagent is one of the best reagent for oxidizing the secondary alcohols. So this is today's about lecture. So we'll wind up here. Okay.